In this tutorial video we are going to demonstrate our Deep Learning Anomaly Detector module. It is an unsupervised machine learning model learning from defect-free images and identifying deviations that indicate defects, useful in applications where defects are rare and varied. To start training your dataset, you can either upload your images or capture them from the camera. In our example we will show how to capture new images from the connected camera. In the top left corner, just under the PEKAT VISION logo, click on the camera icon to view the camera feed. To take your first image, click on the top right icon Capture. As each screw is slightly different and can be rotated in various ways, capture multiple variations, including images of different screws in different rotations. The goal is to create a robust training dataset containing many variations. Remember that only images of defect-free screws are required for training the Anomaly Detector module. To add the Anomaly Detector module, go to the top left menu and select Modules. Click Edit. Then the plus button. Click Anomaly Detector, then Add. Click Save Changes and open the module by clicking at the newly added icon. In the right column you can see the preview of captured images. Now you need to select all images you want to include in the training. Select the images and click on the OK option under the annotation heading on the left. You can select each image individually or multiple images by holding the Control button on your keyboard and clicking the images with your mouse, or by holding the Shift button to select a continuous row of images. You can also use your keyboard. To move among the images, use the up or down arrow keys. To include an image, press 1. Before starting the training, select the optimal feature size. Feature size determines the level of detail that the software focuses on when detecting defects. Since we are looking for relatively small defects in the screws, the smallest feature size, which is also the default, seems appropriate. To start the training, click on Start Training. Choose a module name or keep the default name, and then wait for the training to finish. Now check the inference on the newly trained model. If you encounter unsatisfactory detection, such as in our case where the first image is falsely marked as not good, return to the live camera feed and capture images with incorrect detections. You can also add images containing screws with defects. These images will later be used for retraining or fine-tuning the model. Return to the Modules screen and select the Anomaly Detector module. Click on the Recalculate Threshold button. Click on the image incorrectly labeled as not good and, under Annotations, select OK. Then, click on the image with the defective screw and select NG for not good. Finally, click Submit. We can select the rectangle option for better visual identification of defects. Let's return to the camera live feed to test the model. We can test different orientation of the screw. We can also replace one of the OK screws with one with a different defect, a small hole. We can see that the hole is not identified as a defect. To recalibrate the threshold, we capture the image and return to the Anomaly Detector module screen. Using the threshold area chart, click on either side of the vertical gray line to find the optimal threshold. Then we return to the camera feed to test the recalibrated model. Although the model seems to be calibrated correctly now and the threshold set optimally, verifying the model requires more testing. Firstly, we will test different orientation of non-defective screws to make sure there are no false positives. Next, we test there are no false negatives. We can also replace one screw with an incorrect type of screw. To switch between the processed view and clear view, check or uncheck the process option. The model is now trained and calibrated and you're ready to start your inspection. Thank you for watching. Try PEKAT Vision now. Visit us at www.pekatvision.com or contact us at sales@pekatvision.com.